Hi, chemistry class. This is Hugh again, and today is Tuesday, April 28th. This is our lesson on the mole, and possibly the most important one of the entire course. This is the big concept in chemistry for grade 11. First of all, what is a mole? It's not the animal I'm talking about here. It's a counting unit. By counting unit, it's something like a pair. So you know a pair, two. Three of a kind, or a trio, three. Quartet, like a string quartet, it's always four. Everyone knows a dozen. It's 12. So you may not be aware that there's another one called a mole. It's just like the other ones. It's a number of things. This is how many. That many. It's huge. It is in fact in scientific notation 6.02 multiplied to 10 to the power 23 things. Okay? That is, take that decimal and shift it to the right 23 times, and that is a mole. It's a little hard to conceive how big a mole is, but just as an analogy down here, they've calculated that a mole of rice, if you had a mole of rice, it would cover all the land on the entire planet Earth, and not just cover it, but to a depth of about 75 meters. That's a lot of rice. That's more rice than it's ever been grown in the history of the planet. So a mole of rice or anything that's big would really not be that interesting or important. But what's important is that in chemistry, we deal with stuff that's just really, really small. Those are atoms. And a mole of atoms is not that much. A mole of water is just a sip. You could drink a mole of water, and in one sip, you'd have a mole of water. So it's because atoms are so small that we need a unit, a counting unit, which is so enormously big. But why mole? What's so special about it? Why should we use this number? What's so special about this one? And by the way, we name this number. It's called Avogadro's number. Named after the Italian scientist who first envisioned the concept. Avogadro's number is an enormously big number of things. And what makes it special and unusual, you have to refer to the periodic table. So here's one. And if you notice that we dealt with earlier on the idea that there's a mass number, but then there's an average atomic mass. And these numbers are never exact. This table, by the way, is a real simplification. Oxygen's mass is not 16.00, it's 15.9997, at least to that accuracy. So this is just an estimate, a rounded number. But the idea is that every atom, the mass of every atom is displayed on this table. And what it means is that, say, for example, it doesn't matter, but say for chlorine, an atom of chlorine weighs 35.45. What units? They're called atomic mass units. And they're really not at all useful because they're way too small to be put on a balance. And what the mole does is it takes the atomic mass units and converts it into grams. So what I'm saying is if you had 35.45 grams of chlorine, that would be 1 mole of chlorine. So the special thing about a mole is it converts atomic mass units into grams. So it converts between the microscopic atomic world and the macroscopic world that we can actually measure with our devices. So the atomic mass of oxygen is 15.9997. Sorry about that. Okay, so the atomic mass of oxygen is 15.9997 AMU, or atomic mass units. But the interesting thing is it's also 15.9997 grams for every mole, gram per mole. So for every 15.9997 grams of oxygen is 1 mole of oxygen atoms. Now, these numbers are not exact numbers. When we do problems, I don't mind you using rounded values. So although the true number is 15.9997, I would accept 16 grams per mole for oxygen. Unless we're doing a lab, in which case you should use the exact numbers from the table. Okay? These are from the periodic table. Okay? So when we want to find out, that's atomic mass. Let's say we want to find a molecular mass, or the mass of a substance. We simply sum up or add the atomic masses. So for example, water is H2O. Okay? So it's got 1 oxygen, it's got 2 hydrogens. Now I'll use the rounded numbers from the table. So oxygen, although it's really 15.9997, I'm going to use 16 grams per mole. And hydrogen is 1.01. So we add up 16, 2 times 1.01 is 2.02. That's 18.02 grams per mole. And what that means then is 18 grams of water is 1 mole. Since water has a density of 1, that's one of its unusual characteristics, it also means 18 milliliters of water, really just a sip, is 1 mole of water. That's the mole concept, and it's one that we're going to be using over and over and over again in this course. So it's really important that we understand it. So I will take questions and